Okay, this is section 8.4 on solving equations when variables are on both sides. This is question 7 from page 327. Question 7 says, this is A. We're going to start with A. It says 1/2 of a number is equal to a constant of 2/5 plus a fifth of that number. Okay. Now what I recommend you do is when you see something like a fifth of n, you have to understand that this has different, you can write this a whole bunch of different ways. You can write it in decimal form as being 2/10 of n. You could also write it as being 2/10 of n if you wanted to. But more importantly, if you think of it as being a fifth multiplied by n, then if we think about n as being n over 1, and we multiplied our numerators, 1 times n is n, 5 times 1 is 5, this version of 1/5 n is something we're probably more familiar with, dividing n into 5 parts or dividing it by 5. So because this is true, and because it's usually the way we like to look at things, what I would do first, if this was my question, and I kind of erase this the old-fashioned way, I would take this question and change it into half of n equals 2/5 plus a fifth of n. That's what I would do. And then what I would say is, because you have a whole lot of fractions, we have learned that if you multiply an equation, both sides of an equation, by a common multiple of the denominators, so multiples of 2 are 2, 4, 6, 8, 10, 12, etc. Multiples of 5, which is the other denominator, are 5, 10, 15, 20. So if I choose any multiple of those denominators, in this case the first one is 10, and I multiply both sides by that number, I will create an equation that is 10 times larger on both sides, maintaining this idea of balance. So times 10 on this side, times 10 on this side, balance is maintained. But if I'm multiplying this side by 10, because it's a binomial or two terms, I have to multiply both terms by 10. So what I would do is I would cross-reduce next. So 10 over 2 will become 5 over 1. And if you notice that the denominators now are 1 and 1, which means they don't exist anymore. So all I'm really going to do is multiply the numerators. 5 times n will be 5n. And on the other side, I'm going to rewrite this to make sure I do it properly. The first multiplication is going to be this. The second multiplication will be this. Cross-reduce to get 2 over 1. That's going to work out to be just a 4 when I multiply that out. 10 over 5 will reduce down to 2 over 1. Denominator is 1, so I don't need it anymore. 2 times n will be a positive 2n. Now that we have this simple equation, we have variables on both sides. The easiest thing to do would be to subtract 2n from both sides. Now you could also subtract 5n from both sides. You could also subtract 4 from both sides. All of those first steps will work. And the reason why I want to subtract 2n is because it's going to get rid of it on that side. Now, if I think about what that looks like, 5n's and 4 and 2n's, by subtracting 2n from this side and subtracting 2n from this side, I'm left with 3n equals simply 4. And this idea of balance is struck when I subtract 2n from both sides. And now I have a simple equation where one step where I divide both sides by 3, and n will equal 4/3, or 1 1/3, or 1.3 repeating. And that's your solution for the first one. Second question, B. I always find when you deal with decimal coefficients, it's easier because there's not as much complexity to it. Just straightforward. Oh, that's a minus, not an equals. It's much easier when you have decimal coefficients. In this case, I have variables on both sides. Now this time, if I was to think about what this would look like, instead of having a whole w, I actually only have 2/10 of a w. So if I was to draw it and divide it into tenths, or divide it into fifths, because that's really a fifth, that's how much w I would have, and it's actually negative, which is hard to draw. And a -1 and a 0.1, which is hard to draw as well. And over here I'd have a third of w, which if I drew w again and drew it into thirds, it would be a positive third of w. So when I look at it from a modeling perspective, it's really confusing and doesn't model really well. But as long as you understand what to do on both sides, it makes sense. So the first thing I'm going to do is get rid of W on one side by adding 2/10 of W to both sides. Zero pair there, negative 1.1 is left on that side. And when I combine these two, 3/10, good golly, 3/10 of it combined with 2/10 is going to make 5/10. 5/10 of W, or more importantly, half of a W if you want to think of it that way. Forget I drew that. It's very confusing. And once you have that, divide both sides by that coefficient. And W will be equal to whatever $1.10 is divided into piles of 50 cents. You can make two piles, 2.2. Is that right? Yes. And a negative divided by a positive is a negative. So your solution for the second would be W is equal to negative 2.2. Question number C. Again, an easy question because it's a decimal constant, a decimal coefficient, and an equivalent value that has a decimal coefficient. In this case, you know what? I'm like, if I add 2.3p to both sides, I'm going to have 0 over here, and then I'm going to have 2 more steps. So I'm just going to add 3.5p to both sides. And actually, when I do that, it's wonderful because I end up with a positive coefficient here because a 3.5p and a negative 2.3, I'm just really going to combine the coefficients. So I'm really going to combine a positive 3.5 and a negative 2.3. And if you suck at rational numbers and adding integers that are decimals, make sure you use your calculator. So 3.5 positives plus 2.3 negatives is 1.2. So now you get 1.2p when you combine those two coefficients. Divide both sides by the coefficient of 1.2. And p will equal 5.1 divided by 1.2. So 5.1 divided by, well, it bothers me, 5.1 divided by 1.2 is 4.25. So p has a standard value of 4.25, or 4 25/100ths, or 4 1/4. Question D says, oh, hello. 1.5 or a half as a in part as a distributive property minus E equals 1 1/6 E. Okay. So it looks confusing, but it's not so bad. Again, we're going to simplify this using distributive property. I'm going to rewrite a half multiplied by 1 over 1, and a half multiplied by negative E over 1 equals 7/6 E, or if you want to rewrite that, since it's multiplication, 7/6 E would really be 7E over 6. Because again, 1 1/6 is an improper fraction as this, multiplied by E, which is what a coefficient does. Multiply the numerators, you get 7E. Multiply the denominators, you get 6. So 1/2 times 1, well, that's easy. It's still itself. It's still a half. 1/2 times negative E would be negative, or minus E over 2 equals 7E over 6. Again, I don't want to deal with fractions. I hate them. So before I start getting rid of E from both sides, I'm going to multiply both sides by a common multiple of denominators so that I do not have to deal with fractions. In this case, the number 6 will work nicely because it's a common multiple of 2 and 6. 6 times a half, I'm not even going to show you the work. That's 3. 6 times negative E over 2. If I cross-reduce that, I get 3 over 1. The one denominator disappears, and 3 times negative E is negative 3E. Equals, what a beautiful thing this is, 7E. So now I've taken that equation that was a half minus E over 2 equals 7E over 6, which was confusing looking and awful, and made it into something very simple and beautiful. Add 3E to both sides. 3 will equal 10E. 10E. divide both sides by 10, and E will equal 3/10 or 3/10. Either one is correct. Did anyone try to, just out of curiosity, did anyone try to subtract a half from both sides? Or add E over 2 to both sides first in this step? Did everybody multiply by 6? Is that what you tried to do? No? Nathan, what'd you do? You divided by half. Oh, you got rid of, oh really? Did it work out? Oh, good. This is more easy, I think. I don't know. What's that? Oh, it is still recording. Hi, Mom. My mom watches all these videos. She's a little obsessive. 3/4 multiplied by D plus 2 equals 2/3 D. First thing I'm going to do is just expand this to be 3D over 4. If you want to see why, you can just multiply it by D over 1. It becomes 3D over 4. And then 3/4 multiplied by 2 is 6 over 4. I'm going to keep it as 6 over 4. I'm not going to change it to 1.5. I'm going to keep it as an improper fraction. Equals 2D over 3. Multiply both sides by a common multiple of all the fractions, which is 12. I'm going to do this side first. This can become 4 over 1. 2D times 4 is 8D. Over here, 12 over 1 multiplied by 3D over 4. Cross reduce to become 3. 3 times 3D is 9D. Not 9T, but 9D. 12 over 1 multiplied by 6 over 4. Cross reduce, I get 3 over 1, which is plus 18. Unfortunately, I think I'm going to have a negative coefficient because I only want to do it in 2 steps, not 3. So I'm going to subtract 9D. I don't like to do it, but you'll see why it makes sense in a second. I get 18 equals a negative D, because 8D and a negative 9D make a negative 1D or negative D. And technically, I should show this step. Divide both sides by the negative 1 coefficient, and D equals a negative 18. I think. Is that right? Yeah, good. And that's it. That's E. Is that the last one? Okay. We'll just leave it at question 7. I'll do another video for question 15.